Okay, this is just a quick recap of what you'll need to know about conic sections for Calc 3. And the key thing is basically to be able to recognize from a given equation whether it's a conic section and then be able to sketch it. So there's basically three main types of conic sections because 1 and 2, like 1 is basically a special case of an ellipse. So we have an ellipse, a parabola, and a hyperbola. So let's just go through in that order. Key ways to, actually, let's start with the parabola and then we'll go to the ellipse and hyperbola. So general form, parabola is just a quadratic. So general form will look something like this if it's a function of x. And so key points, I would basically just plot a couple points. I'd basically plot intercepts as a key way. What you're identifying to realize this is a quadratic is that your highest power of your independent variable is just squared, and your dependent variable is just raised to the first power. So yeah, I would plot intercepts. The other thing that you can use is quadratic formula to help you find your x-intercepts, if you remember. And actually right out of the quadratic formula, if you just take this first part, negative b over 2a, that will be the vertex of your parabola. And again, that makes sense if you were recalling when you learned about parabolas. I'll just do one here, right? So here's my vertex x, and then notice that my zeros are an equal distance away from that vertex, which is what the plus or minus of this term is going to help you get. Okay, so that's what I would do. And then as you recall, like obviously we could have a parabola where y is the independent variable, and it'll be a similar idea. It'll just be opening either to the left or to the right. So you can plot and go from there. All right, let's move on to, let's do ellipses. All right, so key things you're looking for with the equation of ellipse is now both your x and your y are going to be squared. And we'll put it in the standard form here. X squared over a squared plus y squared over b squared equals 1. When you get it in this form, it's easy to graph because your x-intercept will just be a and your y-intercept will just be b. So I made this one kind of look like a circle. Let's make it look more elliptical. So that's basically why you want to get things into a standard form. So typically you're going to take an equation that may look a little more confusing, like let's do this one, plus y squared over 2 equals 2. And I'm going to try to get this into standard form. So divide everything through by 2. So I get 36x squared plus y squared over 4 is equal to 1. And then notice multiplying by 36 is the same as dividing by 1 over 36. So this is going to be the same as x squared times 1 over 36 plus y squared over 4 is 1. And then we're just going to take those denominators and write them as something squared. So this will be 2 squared and this will be 1/6 squared. So that's going to give me my intercepts. So this is definitely going to be a very squished ellipse. X, y. On x, I'm literally only going out to 1/6, which is going to be hard to see on my scale. Y, I'm going up to 2, and then I'm plotting this ellipse. All right, so that's the key idea with this. Now, obviously, these ellipses could be shifted. So if I wanted to shift them to a different center, then it'll look something like x minus h squared, and then y minus k squared, and then my new center would be h and k. So this thing would get shifted over, let's say, to have this center here. So you can look for that as well as you're trying to figure out your, as you're trying to figure out what your equation is telling you. And then lastly, we have hyperbolas, which are going to look similar to the standard form for an ellipse, with the exception that now you're going to have a subtraction. So you're going to have different signs between your x and y. Okay, or you might see them like this, y squared. Let's see, do I want to write b or a? Doesn't actually really matter, but I'll do it like this. Okay, so the key things here is when you're sketching, again, the A and B are going to give you some information. What they do is they give you a little box. I draw a little box here. So this is negative A, negative B, and your hyperbola is going to have these lines as their asymptotes. So the question I just have to figure out is, does this hyperbola open up and down or right and left? Typically what I will do is either, I'll just guess, right? Like if it opened right and left, it's going to have this point on it and it's going to go like this. And I can check by saying, does the point A0 work? And if I plug in A0, I do in fact get 1. So I know that it actually, and same thing if I plug in negative A0. So I know it's opening this way, as opposed to if I plugged in 0B, so this point is not on this particular hyperbola, because if I plug in 0 for X and B for Y, I'm going to get negative 1 and not positive 1. So this one has to be opening this way. And then, which is going to actually mean this flipped one will open the other way, but so this is still going to be going out B on the Y, A on the X. It doesn't need to look exactly, I'm kind of making it look like a square. It can obviously have, you know, different proportions, but in this case, 0B is going to be on the hyperbola. So you just draw this with your asymptotes going out towards those lines. And that's the main gist of what we'll need for Calc 3, because we're going to be drawing surfaces where these cross sections are one of these conic sections usually, and you're trying to kind of piece together all these different cross sections to visualize your surface in 3D.